Hello everyone, welcome back to our channel. So today we are back with the second part of solutions of exercise of the chapter motion class 9th. I hope you all enjoyed the previous video. Please don't forget to give us feedbacks and reviews. So today we will be solving the rest of the questions in the exercise. Let's get into that. First of all, the fifth question. A driver of a car traveling at 52 km per hour applies the brake and accelerates uniformly in the opposite direction. The car stops in 5 seconds. Another driver going at 3 km per hour in another car applies his brake slowly and stops in 10 seconds. On the same graph paper, plot the speed versus time graph of the two cars. Which of these cars traveled farther after the brakes were applied? Okay, so they are asking us to plot the velocity or yeah, speed versus time graph. Okay, so there are two cars. Okay, speed, time. Okay, the speed is given in kilometer per hour, time is given in seconds, isn't it? So the first car is traveling at 52 km per hour and applies brake and the car stops in 5 seconds. Okay, so let's mark time. This is 5 seconds, 10 seconds, 15 seconds. And the speed of the car initially was 52 km per hour. So let this be 10, 20, 30, 40, 50. Okay, so 52 km per hour, almost here. So that's the speed with which the car decides to stop. Okay, at which car decides to stop. And within 5 seconds the car comes to a stop. So the graph would be like this, isn't it? Next, another car which was going at 3 km per hour and it applies brake and stops in 10 seconds. So 3 km per hour would come somewhere here. Okay, for simplicity I am drawing here. It's not to scale because 3 km per hour would be very small. So this is 3. Okay. Yeah, and it comes to stop within 10 seconds. Okay, so on the same graph we have plotted both the velocity versus speed versus time graphs for both the cars. So which of these two cars traveled farther after the brakes were applied? So the question is very simple. They are asking us to find which of these two cars has traveled the farther distance after the brakes were applied. So that's we know that this is a speed time graph. Okay, an area under speed time graph gives distance, isn't it? Why? Because speed is defined as distance upon time, isn't it? From this, distance is speed times time. So an area, the area under the speed time graph gives us speed. So let this be car A and this be car B. For car A, we will calculate the distance. For car A, what is the area under this triangle? Okay, so under this triangle, we can see the area is equal to half into base length is 5, isn't it? And height is 52 km per hour. So we need to convert this 52 km per hour into meter per second. Okay, because we need to be consistent. Here the time is given in seconds. If the time was given in hour, we can directly calculate it, directly substitute the values. So 52 km per hour. How do you convert kilometer per hour into meter per second? 52 km per hour. So that would be equal to 52 into 1000 divided by 1 hour is equivalent to 3600 seconds. So this calculation will give us the speed in meter per second. So if we simplify this term, it would be 5 by 18. Okay, just remember this because in many questions the speed value will be given in kilometer per hour, but actually in calculation we might have to use in meter per second. So this conversion, just remember them. Okay. So what will be this value? 52 into 5 by 18. It would be 52 to 10 to 26 divided by 18. So 130 divided by 9. That would be 19 40 4 9s are 36, then 44. So I guess it would be something like 14.4. I'm not sure about the math. So that means meter per second. Okay. So now we got the speed of this car A in meter per second. So we can substitute this value here. 14.4. So our answer will be 5 into 7.2. 35 meters. Okay, 35 meters is the amount of distance that the car A has traveled. Okay. Now we need to find the distance that the car B has traveled. For car B, again, we have to do unit conversion. So what was the, how many kilometers, what was the speed? The speed was 3 km per hour. Okay, so if we convert 3 km per hour, it will be 3 into 5 by 18, isn't it? So this is 5 by 6. What is the value of 5 by 6? Okay, let's calculate it. Okay, that would be 0.83 meter per second, isn't it? Yes. So the area would be for car B, half into 0.83 into, what is the length is 10 seconds. That's like 8.3 divided by 2, 4.15 meter. So car B has traveled 4.13 meters after brakes were applied, and car A has traveled 35 meters after brake was applied. Okay, so I guess the question is clear. The only thing that we have to do is to calculate the area under the graph of the speed time graph, which will give us the distance. Another thing that we need to be careful about is that to convert kilometer per hour into meter per second. Okay, now let's move to the next question. Question number 6. In question number 6, we have a figure. Figure 7.10 shows the distance time graph of 3 objects A, B and C. Study the graph and answer the following question. Which of the 3 is traveling fastest? Are all 3 ever at the same point on the road? How far has C traveled when B passes A? How far has B traveled by the time it passes C? Okay. So this question is a little bit tricky. You have to be careful with this question. Okay. So we are given a distance time graph. Okay. And there are 3 objects A, B and C. Okay, 4, 8, 12. 4, 8, 12. And here we have 0.4, 0.8, 1.2, 1.6. 0.4, 0.8, 1.2, 1.6. Okay. Okay. So car A, actually this is again further subdivided into, if you see the textbook, you can see that these are further divided into lines and columns. So each unit, like there are like 7, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, one unit is divided into 7 subunits. So it's we need to be careful with this. 1, 2, 3, okay, 4. So actually car A starts from around half of 4 and 8. So around like from here. From here it goes to more than 1.6. So it goes like to up to here. That's about car A. Now car B. Car B is starting from origin. Okay, and it is going up to 1.2. Oh, like here around. That's like here. Okay. So that will be like here. So this is car B. And now we have car C. Car C is starting from here. And car C is going to cross car A at around 1.6. Or yeah. 1.6 is somewhere here. This is car C, isn't it? Okay. So now there are certain few questions are given, follow-up questions. So which of the three is traveling the fastest? Among car A, B and C, which of these cars are traveling the fastest? Okay. There's confusion. This is B, this is A, and this is C. Okay. Which of these are traveling the fastest? The answer is very simple, right? I don't know if I have mentioned before. Like we know speed is equal to distance by time, isn't it? So distance by time. I hope you guys know how to calculate the slope of a line. So if this is a straight line, you draw a line if we take a point, we draw a line parallel to y-axis. And from another point we draw a line parallel to x-axis. Okay. Then we consider this small triangle and we need to find this distance and this distance. So we divide this y distance by x distance, which will give us the slope of the graph. So similarly here we have distance by time. So here we will take time on the x-axis and distance on the y-axis. So the slope is actually a measure of this ratio, and speed gets higher when this ratio is large. That means when the slope of this graph is the highest or the steepest, you can say that the speed of the vehicle is the highest. That means if we have three graphs like this, okay, one like this, one like this, one like this, one like this, the slope is like this has a zero slope, this has a significant slope, this has even higher slope, this one has the highest slope, and this one has infinity slope. Okay, so that's what here we need to use. So from this it is obvious which car has the highest speed. It would be car B, because the slope of car B is the highest. This is the steepest line among the three lines. Okay, so I guess that answer is clear. Now there's the second question. Are all three ever at the same point on the road? Obviously no. At this point cars like B and C, B and C are at the same point on this point. At this point cars A and C are at the same point, at the same position, and on this point cars B and C, car B and C are B and A are at the same point. So you can see that. But all three are not all three lines are not intersecting at one common point. Only if all three of these lines intersect at one single common point, you can say that they all have came together at one particular point on the road. Okay, next two questions is a little bit mathematical. How far has C traveled when B passes A? Okay, so when does B pass A? So this is B and this is A. Sorry, which one is A? This is C. Let me redraw this. Okay.
That I.
Okay. Okay. So this is C. This is B. Sorry, A. So they have told us that when B passes A, so this is B, this is A. This is A, this is B. So this is the point when C passes B. Okay. So when B passes A. Okay, at this point B passes A, and the corresponding point is this one. This is where C is at that time. So we need to calculate what is the distance covered by C at this particular point, isn't it? How far has C traveled when B passes A? Okay. When B passes A, how far has C traveled? So from that you can see that that is almost at 8 kilometers. This graph is not very good, but it almost comes parallel to 8 kilometers. So when B passes A, this is the position of C. Okay, and if you check the graph given on the textbook, you can see that it would be at around 8 kilometers. C has traveled 8 kilometers. Okay. Now next question asks us, how far has B traveled by the time it passes C? Okay. C has traveled. Okay, so we made a mistake actually. I forgot that. See, when B passes A, the position of C is here. But the question that asked to us is, how far has C traveled? That means C is starting from 4. This is the line of C, and it has reached this 8. So how far has C traveled would be that distance, right? Yeah, how far has C traveled when B passes A? When B passes A, C would have traveled this distance. Okay, I made another mistake. See, the graph is not like this. That's why I was making mistakes. It's like starting from here, and they are crossing at around 1.6. 1.6 is here. Yes. Okay, sorry for that. And that is A, and this is B. So C is actually starting from here. Anyway, okay. So this is the position. Correspondingly, this position is almost parallel to 8. So C has reached the point 8, like at 8 kilometers when B has passed A. Now we need to find the distance traveled by C. So that would be from here to here. Whatever this value, that would be the value. But what is this value? This value is actually, if you look carefully, I guess 1, 2, 3. It's on the third line. 4, 5, 6, 7. Okay, so it's like on 3. I would say it would be like on the like 3 units have covered. The car is like in between 3 units. So that would be 3 by 7 of 4, right? 3 by 7 of 4 into 4, I guess. Yeah. 4 is divided into 7 units, and in that the third unit, isn't it? How much would it be? Around 12 by 7. 12 by 7 is like 1 point something. Okay, it's like slightly under 2 kilometers. Anyway, that is the initial position of C. From there it has reached 8. From this position it has reached 8. So the distance that it has traveled, this is the initial point of C, and this is the final point of C. So the distance it has traveled is 8 minus 12 by 7. Okay. So that would be 56 minus 12 by 7. That would be 44 by 7. Okay. So around 6.28 kilometers will be traveled by car C. Okay. So this is a rough calculation. There would be mistakes. So you need to do it more carefully, okay? Next question is, how far has B traveled by the time it passes C? So when is B crossing C? So this is C, this is B. So here our B crosses C, isn't it? Let us see the graph on the textbook. So yeah, here only B and C crosses over here. So that's actually at around what, 3 lines after. Okay, that's actually like at 3 lines after 4 on the third line. Okay, so this is like 3 units again. So that's like 4 into 3 by 7 plus 4, isn't it? Because each 4 kilometers, this is 4 kilometers. 4 kilometers are divided into 7 sections. Among that, this is like at the position at which B crosses C is the third line. Okay, out of 7 lines. So that's like 4 by 7 into 3. So that is just this distance. Plus 4 kilometers you have to add. Plus 4. So 12 by 7 plus 4. Isn't it? 12 by 7 plus 4. 12 plus. Okay, so that's like 40 by 7. What is 40 by 7? 5.7. Okay, 5.7 kilometers. I guess that answer is also correct. Okay. So these are rough calculations. You need to look carefully at the diagram given and like count the units that it has crossed. This 4 by 7 could be wrong, but it's almost like this. This is the procedure that you have to follow. Okay. So thereby we calculated what is the how far has B traveled when, sorry, how far has C traveled when B passes A, and we have also calculated, this calculation corresponds to how far has B traveled when it crossed C. Okay, so that was a lengthy question. Now let's move to the next question. Okay. I guess the next few questions are easy. Okay, so we have solved 2 questions, and I guess let's wind up for today because it's taking too much time. The video length would be too big. So I guess we have like 4 more questions which we will try to solve in the next video. Okay, so for now I'm saying goodbye. See you in next video.